Hello, welcome back. The title of this lesson is called Multiplying Decimals Using Models. This is part one. Probably a better title would be Understanding Decimal Multiplication using pictures or using models. I'm really excited to teach you this because you'd be surprised how many people, adults, don't really understand what it means when you multiply a number times a decimal or a decimal times a decimal. You know, we learn how to do it in school, but a lot of times people don't really understand what it means to multiply by 0.3 or multiply by 0.4 or whatever. So here what we're going to do is you will understand by the end of this lesson exactly what multiplying by a decimal does and what it means. And as we build those skills in the future lessons, we'll do a lot of practice with decimal multiplication to get the hang of it. So the first way I want to talk about this is I want to talk about multiplying something times 0.5 because it's the easiest thing to do. In the back of your mind, as we talk about this discussion, when you think of 0.5 of something, I want you to think of 0.5 means the same thing as half of something. Decimals and fractions go together like peanut butter and jelly, and I want you to remember that 0.5 is exactly the same thing as 1/2 of something. So 0.5 is the same as 1/2 of something. So for our first problem, we want to look at this problem here. 0.4 times 0.5. Now I'm going to teach you how to do this by hand by doing the actual multiplication in a future lesson. This lesson is nothing to do with that. This lesson is for us to understand what does this actually mean. All right, so what we want to do first is we want to understand that if I were taking 0.4 times, let's pretend for a second that we're not actually multiplying by 0.5. Let's pretend we're just multiplying by 1. What happens when you multiply something by 1? It means you just keep the same number, right? 2 times 1 is 2, 3 times 1 is 3, and so on. So if it were 0.4 times 1, the answer would just be 0.4, but we're not multiplying by 1. See, when you multiply by 1, it keeps the number unchanged, right? But here we're multiplying by 0.5, which is the same thing as half. So what I want you to start thinking about is when you multiply, the thing that you're multiplying by, when it's a decimal like that, I want you to think of that second thing you're multiplying by as like a chopping function. I'm using my hand here to think, I want you to think of chopping. So what you're doing is you're taking something that's 0.4 and you're chopping it in half. That's what, if you read it out loud, you're taking this, you're chopping it by this amount. And this decimal amount of 0.5 is the same thing as cutting it in half. If we were chopping this thing times 1, then nothing would change. It would be 0.4 times 1 is 0.4. But we're multiplying by, instead of 1, we're multiplying by a half. So we're chopping it in half. So whatever we start with, when we multiply by 0.5, we're just cutting it in half, and that's going to be what the answer is. We want to now draw pictures to show what this means. First of all, we have some diagrams here. I know it looks confusing. I want you to completely ignore this on the right. This little diagram is going to represent the 0.4, and this little diagram is going to represent the 0.5. Now, before we do anything else, I'm going to draw kind of under here, I'm going to put that this is one whole. And this thing right here is also one whole. So this box here, it represents 1. And this box, this entire box also represents 1. For now, completely ignore the answer. I don't want you to look at the answer, all right? So if this represents 1, then what is 0.4? Remember, the first decimal here, 0.4, is the tenths place. That means that we take whatever we're talking about, we chop it into 10 pieces, and 0.4 means 4 out of 10 pieces because it's the tenths place. So if we want to represent 4 out of 10 pieces, notice I've already chopped this into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. This is 10 equal pieces. This whole is cut into 10 equal pieces. So if we want to represent what 0.4 really looks like, then we'll take the whole and we will only discuss or talk about 4 of those 10 pieces. So there's 1 out of 10, 1/10. Here's 2 out of 10, 2/10. Here's 3 out of 10, which is 3/10. And here's 4 out of 10, which is 4/10. So this shading of this much of the whole represents 0.4. How do we know that? Because 0.4 is 4/10 or 4 out of 10 pieces. We've taken a whole thing, we've cut it into 10 pieces, and we only shade 4 of them. So this box here, this shaded region here represents 0.4 of something. You can think of this being like a sandwich, and if you cut this much of the sandwich away, then this is 0.4 of the sandwich. So that's the number we're multiplying to begin with. Now, what are we going to chop it by? What are we going to multiply by? We said if we were multiplying by, instead of this, 1, then this whole thing would be shaded with 1, and then the answer would be exactly the same. 0.4 times 1 is 0.4. Nothing changes. But we're multiplying by 0.5. Let's write down what 0.5 would look like on here. I have this box again into 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. So what we want to do is we want to represent that in terms of a picture. So 0.5 means 5 out of 10 pieces. So here is 1 out of those 10 pieces. Here's 2 out of those 10 pieces. Here's 3 out of those 10 pieces, 0.3. Here's 0.4 because it's 4 out of 10 pieces. And here's 0.5, which is 5 out of the 10 pieces. Notice that this represents half. It's literally half of the entire object. If you cut this entire thing in half, this is a half and this is the other half. So I told you in the beginning that 0.5 is the same thing as 1/2. This is why. Because if I take an object and cut it into tenths, like 10 pieces, tenths, and I shade 5 of the 10 pieces, I'm going to have half of it. So when you multiply by 0.5, you're chopping it by this. So I'm going to write here chop. Right? So the multiplication means chop. You take what you start with, which is this much of a sandwich. And this second picture is only telling you how much you're chopping it. And in this case, we're just chopping it in half. So if I know that I have this much of the sandwich, which is less than half of it to begin with, and this is telling me when I multiply that I'm going to chop this in half, then I know without doing any math that the final answer is just going to be half of what I started with because I'm multiplying by 0.5, which is a half. So before I do anything else over there, I know that the answer is going to be about this much because it's going to be half of what I started with. So what I want you to do in your mind is I want you to use this as a chop. We can kind of extend this. You can kind of like extend this over here and kind of like do it a little dot, dot, dot. I'll kind of like do it right here, I guess, a little dot, 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 because we're going to chop this in half. This amount is used to chop this thing in half. It's to chop this thing in half. So I can kind of go through here like this. And I know over here that I had 4 columns. So I can kind of like reproduce 1, 2, 3, 4 columns. I can kind of like go through here. And you see what I'm doing? I'm finding where these intersect, which is all of this right here. All of this right here. Because literally all I have done is I've taken what I've started with, which is this much, 0.4 of a sandwich or whatever. And I've multiplied by this, which is a chopping factor. This tells me how much to chop, which means I chop this much away, and that is how much I have left in my answer. So then, in order to figure out what the answer is going to be, I need to count squares over here, right? Because if I take this and I slice it this way, I'm going to be dividing these into more squares. So notice here these were sliced into 10 equal pieces, and this is sliced into 10 equal pieces. But once I do the chopping, now it's like the whole entire sandwich is chopped into how many pieces? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 this way and 10 this way. 10 times 10 is 100. So this answer here is represented out of 100 pieces of the sandwich. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 hundredths. So the answer is going to be 20 hundredths, 0.20, right? Because when you read decimals, remember, you take a look at how many spots you have. This is the tenths place, and this is the hundredths place. So if you look at the whole number, it's 20 out of 100, because this position here is the hundredths place. So you read everything after the decimal. 20 is what's after the decimal, but it goes to the hundredths place. So it's 20 out of 100 pieces. So 20 hundredths. So 0.20 is how we represent that. Now, getting the answer in 0.2 is something I'm going to show you how to do later, but you can kind of think about it. It makes sense, because if you start with 0.4 and you cut it in half, it makes sense that the answer should be 0.2, because half of 4 is 2, right? That's what makes sense. We're going to learn how to do it, by hand in a minute, but for now, again, just want you to realize when you take something and cut it into 10 pieces and take 4/10, and then you multiply it by 0.5, which means you cut it in half. You chop it. This is the amount that I have in my answer. but I'm going to express the answer in terms of hundredths, because then I can line up everything properly and count the squares here. So I cut it into 100 pieces and I have 20 of them, so 20 hundredths. The answers that you get here, I don't really care that much if you're getting the correct answers yet, because I'm going to show you how to multiply by hand. Right now, what I'm really trying to teach you is to multiply decimals. You're taking the first number, and the second thing, the thing you're multiplying by, is like a chopping factor, which just cuts the thing in half. And we're expressing the answer in terms of hundredths, because that way we can just fill the squares out here and write the answer down. So that was our first problem. We had to do a lot of talking for that first problem. I think before I do the next problem, I want to take a step back and just kind of like talk a little bit more for a second. Let's just say, forget about pictures for a second. What if I ask you, what if I take the number 8, not 0.8, just 8, and I multiply it by 0.5? Now that you know what's happening here, what do you think is going to happen? What you're telling me, or what I'm telling you, is that if I take 8 bananas, and I multiply it by 0.5, I'm chopping it by 0.5. We know that 0.5 means a half. So when you multiply, it means chop. It means chop it by that much, by that factor. If we take 8 bananas and we chop it in half, what do we have left? 8 bananas. When you cut it in half, how many do you have? 4. Now, I'm going to show you how to do it by hand, but I want you to know what it means. And 8 times 0.5 is 4. What if I give you, 16 times 0.5? We're going to take 16, pumpkins, and we're going to chop it in half, because 0.5 means a half. And so what's going to happen is you take this and cut it in half. So you're going to basically write that down and look at it. You can convince yourself that that's equal to 8. 8 times 2 is 16. So when we cut this in half, we know the answer is 8. When we multiply by 0.5, we cut things in half. When we multiply by 1, we don't change anything. When we multiply by 0, we get 0. And anything in between that we multiply by, any decimal, is just going to chop it by that much. So for instance, if we're just thinking about it here, if we have 0 right here and we have 1 right here, we're going to write down chopping factors. When we multiply by 0.5, where does 0.5 live here? Between 0 and 1, exactly in the middle is 0.5. 0.5 is half. So it's right in the middle. It's between 0 and 1. It's called 1/2. What I'm trying to get you to see is that if you take a number and multiply it by a chopping factor, if we multiply by 0.5, we're multiplying by a half, so we cut it in half. If we multiply this by 1, anywhere over here by 1, then we're going to get more and more of the original thing. So 16 times 1 would be 16, right? If we go the other direction here and multiply by 0, 16 times 0 is 0. So if we multiply by 1, we get the original number. If we multiply by 0, we just get 0. If we multiply by a half, or 0.5, we get half of what we started with. If I multiply by some number over here, like this number might be 0.25, or a number over here, this number might be 0.8. All that's happening is you're chopping it by more. If I multiply by 0.8, then I'm going to get something closer to 16. If I multiply by 1, then I'll exactly get 16. If I multiply by something less than 0.5, I multiply by 0.25 or 0.1 or something even lower, then I'm chopping and getting less and less and less. All I'm trying to get you to see is when you multiply by decimals, that second thing you're multiplying by is a chopping factor. The closer your chopping factor is to the number 1, then the closer you get everything that you started with. But the farther away your chopping factor is to 0, the less you get what you started with. And if you chop exactly by 0.5, of course, you just cut the thing in half. And so now that we have the idea, let's fill out the rest of these problems. They're going to go very fast now. What if we start with 0.2 and we multiply by the chopping factor of 0.8? So we're going to start with this, and we're not going to cut it in half. We're going to get more than half of it because we're chopping it by something bigger than a half. We're chopping it by something bigger than a half. So 0.2 would be 2 out of 10 slices of something. So this thing is cut into 10 pieces. 0.2 is equal to this much of whatever you're starting with. And I'm multiplying by 0.8. And that means I'm multiplying by something. I'm multiplying something by something that is much larger than a half. I'm multiplying by, here's 1, Here's 2 out of 10. Here's 3 out of 10. Here's 4. Here's 5. Here's 6. Here's 7. And here's 8. 8 out of 10. So this is my chopping factor. I'll just write it on the top here to remind you. Chop. This is what you're chopping by. So if I put a little dash line through here, and I can carry that dash line over to here, then I can see what's going to happen. If I start with this much, and this is a chopping factor, it's telling me that I'm only keeping this much of it. I'm throwing the rest away, and I'm chopping, and I'm keeping all of this. If I were to chop with a factor of 1, that would be the entire thing, and then I would keep everything, because something times 1 is itself. But you can see here that by chopping by this much, I'm only going to keep this amount. So I go over here, and I shade that amount. And so it was the first 2 columns up until this point. So I can kind of fill these out like this. And then I can, instead of expressing in tenths, I'll express these squares in hundredths. How many hundredths do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 hundredths. 16 hundredths means 0.16. This is the tenths place. This is the hundredths place. So when you read it, it's 16 hundredths. 16 squares out of 100 is how much I keep whenever I start with this much and I chop it by this much. All right? Just like here, we had 20 squares, so it was 0.20. So 0.2 times 0.8 is more than half of what I started with, and it comes out to be 0.16. Again, we're going to be doing these by hand in a few lessons, showing how to do the multiplication. Here, we're just trying to understand what's going on. All right, let's take a look at the next 2 problems. We only have 2 more in this lesson. Here, we start out with 0.7, and we're not going to cut it in half. We're going to cut it less than half. 0.5 would be cutting it in half. We're cutting it in less than that. We start out with 0.7. So here's 1 out of 10. Here's 2 out of 10. Here's 3. Here's 4 out of 10, or 0.4. Here's 0.5. Here's 0.6. And here's finally 0.7. So this purple shaded region represents how much we start with. Now we're chopping by something less than half. So we'll go over here and say 3 out of 10. We're chopping by, here's 1 out of 10, or 0.1. Here's 2 out of 10, or 0.2. Here's 3 out of 10, or 0.3. This is what we're going to use to chop what we have over here. So we'll just draw a little dotted line through here. This is how much we're going to keep. That's what we chop. So we will just extend this over here. And then you can see, of course, it went to 0.7. So 1, 2, 3, 4, 5, 6, 7 columns. It kind of went to right here. And then you can see if we just kind of like copy it here, we're going to shade all of this right here. Notice it's exactly this amount. This amount right here, this amount of stuff is what we're shading right here. We're just chopping it into 100 pieces so we can express it better. So we can express the amount better. How many squares out of 100 do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 squares out of 100. 21 out of 100, 21 hundredths, 0.21. Tenths place, hundredths place, read it together, 21 hundredths, 21 out of 100. So 0.7 times 0.3, when we do it by hand later, we'll find out that it comes out to exactly be 0.21. And that's what this is representing, is we take this thing and we chop it by something just a little bit less than half, and we get a number of 0.21, which represents about less than half, a little bit less than half of what we started with. All right, here's our last problem for this lesson. We're going to take 0.8 and we're going to multiply by 0.4. So we're going to start with this amount and we're going to chop it pretty close to halfway, but not quite. Here we were chopping by 0.3. Here we're going to chop a little bit more, but it's still not quite halfway. It's a little bit less than half. 0.5 would be chopping it in half. So let's represent 8 tenths. Here's 1 tenth, 0.1. Here's 0.2. Here's 0.3. Here's 0.4. 0.5. 0.6. 0.7. And 0.8. So this entire purple shaded area means 8 tenths of a whole. It's less than a whole. It's 8 tenths of a whole. Now this guy over here, we're chopping it by just a little bit less than half. So let's see, out of 10, here's 0.1, here's 0.2, here's 0.3 or 3/10, and here's 0.4, which is 4/10. Notice that going one more up would be exactly half. This is just a little bit less than half. So then we will take and we will cut and literally chop this thing by that amount. And this is what the answer will be, this much stuff. We start with this, we use this to chop it, and this is all that we have left. It should be a little bit less than half of what we started. So we go over here, we can extend this line, see if I can make it line up exactly, yeah. And then we need to go over to here as well, and then we can start shading. So here is, make sure I don't overshoot here. Yeah, it goes to this far, like this. Make sure we catch everything over here. And we're just basically shading what the answer is, which we already have, but now we're representing it in hundredths because we can represent the exact answer. Notice this is the answer after we chopped it. We're just taking that and cutting the whole thing into 100 pieces to see how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. 32 squares out of 100 is 0.32. This is the tenths, this is the hundredths. Read it together. It's 32 out of 100. So, in this lesson, we have learned, believe it or not, something really important. I do not care if you know that 0.8 times 0.4 is 0.32. I do not care if you know that 0.7 times 0.3 is 0.21. I don't care about that. I will show you how to write it down and calculate it in a few lessons. All I care about is you understand what's happening. The first number is just something less than 1. It's represented by a shaded region. The second number you multiply by is a chopping factor that tells you how much of the first thing we're basically going to chop and throw away. So if we start out with this much of something and we chop it by exactly 1/2, this represents 1/2, this represents the chopping factor, then literally this is the answer. We take that answer and represent it in hundredths. In this case, we had 20 squares out of a total of 100, so the answer was 0.20. If we take something and multiply by a chopping factor larger than 0.5, then we're chopping a larger amount and we're going to keep more than half of what we started with because we're chopping it by something bigger than 1/2. We count the squares, get 0.16 squares out of 100. If we chop by something less than 0.5, both of these cases, here we're chopping by 0.3, here we were chopping by 0.4. In both cases, we used it to just cut what we started with, and then our answer is what's going on here. So when you're multiplying by decimals, you're chopping. It's like you have an axe and you're cutting the tree down. The chopping factor, the thing you're multiplying by, is just telling you how much to chop away. That's it. As we go through the next lesson, we'll get a little more practice with these kinds of problems. And then as we move beyond that, we will learn how to write these down and calculate the answer. But when you get the answer, you'll know what it means. And again, as we said before, if you take something and multiply it by 0.5, you're cutting it exactly in half. If you multiply by something more and more and more than 0.5, then you're going to keep more and more and more of what you started with till you get to the point where you just multiply by 1 and then you keep everything. 16 times 1 would be 16. If you multiply by less than 0.5, you get closer and closer to 0, so that eventually, if you multiply by 0, you'll just get 0. So that's why I say we're multiplying by a chopping factor. Watch this a second time. I really think it's important. Move on to the next lesson. We'll do more practice with these pictures, and then we'll start multiplying decimals by hand.